All right, Hi Algebra 2. This is your quick review of absolute value equations and inequalities. We have done both. We have graphed an absolute value equation on a two-dimensional coordinate plane, and we've also graphed and solved absolute value equations on a one-dimensional linear graph as well. So we're going to do both. If you guys take a look at the left-hand side where it says, how can we solve an absolute value equation? The example for this would be if you guys were given something with just one variable. So for example, -2, absolute value, x minus 3, close absolute value, is equal to -6. The steps that we discussed in class were, to number 1, isolate the absolute value. Okay, get the absolute value part alone, which means the straight lines with the stuff in the middle needs to be by itself. So when I look at this one, I see a -2 that is in front of the absolute value symbols, and I need to get rid of that -2. -2 is directly in front, and there's nothing in between. So if you notice where I just put my red dot there, there's nothing in between, which means -2 is multiplying by the absolute value. So I'm going to divide by -2. Whatever I do to one side, I must do to the other. And now I can write down that I have absolute value of x minus 3 is equal to 3. At this point, I can set up my two cases. Remember, we were talking about how absolute value accounts for a positive and a negative direction, and you're talking about the distance away from that central point. Usually 0, but it could be a different central point as well. So when I see those absolute value symbols, I need to set up the positive and negative case because I'm accounting for two separate cases. Well, if that's what I've got to do, that means once I have the absolute value isolated, I can set up my x minus 3 is equal to 3. But I could also say that that middle x minus 3 could be equal to -3. I'm not sure. That's why I'm checking which ones will actually work. I will solve these like a regular one-step equation, add 3 to both sides, and now I have x equals 6. That's one possibility. And if I add 3 to this side, I'm going to get x equals 0. That's another possibility. My last step is to check, or verify is another word you guys will see. Verify your solutions. If I verify, I use the original. So I'm going to go back to the -2 multiplied by the absolute value of x minus 3 is equal to -6, and I want to see if that's actually true. Are the two x values that I found actually working for the original problem? So -2, my first x value is 6, so I'm going to replace 6 as my x. I always want to do order of operations, so I'm going to look inside of the absolute value first. 6 minus 3 is 3. The absolute value of 3 is positive 3. Multiplied by -2 makes -6. There we go. So -6 makes -6. That is true. So that one works. If I want to check the other one, I'll have to do the same. I'll have to say -2, and then I'm going to replace 0 for my x. Should give me -6. Look inside the absolute value first. -0 minus 3 makes -3. But remember, those straight lines around the -3 mean the absolute value of 3, which is always positive. So positive 3 multiplied by -2 also makes -6, which is correct. So both of those answers do work. I verified it. I'm correct. So 6 and 0 both work for this absolute value equation. When I look for an absolute value equation in two dimensions, what you guys are doing is you're using transformations from the parent function. So that word parent right there the parent function, like where we come from. The absolute value function, parent function is absolute value of x. And we discussed that as starting on 0, 0, and then has a slope of up 1 over 1, up 1 over 1, up 1 over 1. Okay? There's my absolute value parent function. Y equals absolute value of x. But an example would be, you guys might be given y is equal to negative absolute value of x plus 1. If I look at something like this, remember that in front of the absolute value, the negative makes it reflect if it's negative 1, or it might make it stretch if there's an actual number that is in front of the absolute value. So we looked at a basic function and we said that, well, if I have y is equal to, if there's some number in front of the absolute value, and then there's an x minus some number on the inside, we're letting h represent that one, plus some number on the outside. These are all the different transformations that could possibly happen to my parent function. My parent function wouldn't have any of these a, h's, or k's. It just has the absolute value of x. But when I see this a value, that is either a reflection or stretch or both. The h value moves left and right. And the k value is going up or down. Okay? So what I'm looking at here in my example is I do reflect. So instead of opening upward, my v shape, my absolute value, is going to open downward. And I also have this plus 1 on the inside. When the plus 1 is on the inside of the absolute value, it moves to the left. If it was minus 1, it would move to the right. So my plus 1 is going to move left 1. So now I'm here. I'm going to make this one red. And I'm also going to reflect downward. So instead of opening up and traveling up 1 into the right 1, I'm going to go down 1 into the right 1. Okay? And because it's a V shape, I can also go down into the left. And then this is actually what my function looks like. So I'm not on 0, 0 anymore. If you look at the vertex, my vertex is not on 0, 0 anymore. It has moved to the left. How does this change when I have an inequality? Inequality, again, will wind up having more than one answer because you're starting to shade and you're starting to look at, okay, well, what other possibilities are there? So on a graph, we represent that by shading possible answers. Let's go through an example for this one. If you guys are given 2 minus the absolute value of x plus 3, and then I'm going to have greater than negative 4. Okay. Go through the same steps that we did on the last slide when we had an absolute value equation. I am going to first isolate the absolute value. In order to isolate, I must get rid of the 2, and I have this negative sign in front of the absolute value. The 2 is separated by that minus sign, which means to get rid of a positive 2, I must subtract 2 from both sides. Once I subtract 2, 2 minus 2 is 0, so those are gone. So all I have is negative absolute value of x plus 3, and I subtracted 2, so now I have negative 6. The negative that's in front of the absolute value is a negative 1. Think about what we did in the last example when we had this negative 2 right here. To get rid of that negative 2, because it's a coefficient, we divided. We are going to do the same thing here. We divide by negative 1 on both sides. Since I am dividing by the negative 1 divided by negative 1 will cancel out because that makes positive 1. Negative 6 divided by negative 1 will make a positive 6, which is fine. However, because I divided by a negative, I must switch my inequality to the other direction. So now I have the absolute value of x plus 3 is less than positive 6 because I had to switch my inequality since I divided by a negative number. All right, let's look back at our steps. My steps were to isolate the absolute value. Step 2 is to set up a positive and negative case. So now we are going to set up my positive case, which is just x plus 3 is less than 6. It pretty much is the exact same expression without the absolute value symbols. My negative case is x plus 3 negative 6. However, because I now have multiplied by a negative, my sign has to switch in the negative case. I solve it just like I would an absolute value equation. So I'm going to subtract 3. And I have x is less than positive 3 as one of my answers. And then if I subtract 3 over here, I have x is greater than negative 9, which is also one of my possible answers. Okay? Now when I have more than one answer, because these are inequalities, I can also graph them on a number line. Before, when I graphed it on a number line, I would just get points because those are my possible answer choices. But now let's go ahead and try to graph on a single number line. I have negative 9 and positive 3. I have an open circle because they are strictly less than or greater than. They do not have the equal to line underneath them. And I'm saying x is smaller than 3. I go this way. X is greater than negative 9, so I have to go this way. So they meet in the middle. What are some of my possible answer choices that will satisfy this absolute value inequality? Any number between negative 9 and 3, but not including negative 9 and 3 because they have that open circle there. So 1, 0, negative 5, negative 4, any of those numbers that are between negative 9 and 3 will work. How do I write this in interval notation? Interval notation is when you start and finish. You're just writing where you start and finish. So I start at negative 9, and I end at positive 3. I do not include either of them, so I put parentheses around negative 9 and 3. If they were solid circles, then I would use the hard brackets. And set notation is when I use my squiggly brackets, also known as braces. I am talking about x in this problem. I use a straight line that means such that, and then I just put my answer in there. I start at negative 9, it's less than x, which is less than 3, and then close my brace. If this were a two-dimensional problem, for example, if I was asked to graph y is equal to absolute value of x plus 1 minus 5, if I switched the equal to a less than or equal to, how would this change my graph? So my parent function starts on 0, 0, but for me, I need to move left 1 because of that plus 1 on the inside of the absolute value, and then I need to move down 5 because of the minus 5 on the outside of the absolute value. So I'm going to go from 0, 0, I'm going to move left 1, down 5, which puts me about here. I did not reflect because I don't have a negative sign in front of the absolute value, and I didn't stretch because I didn't have a number in front of the absolute value. So I'm just going to go up 1 over 1, and it is a solid line. Whoop. Try as best as I can. There we go. Smart word's a little off, but that's okay. I have a solid line, and y is less than. So I'm choosing to shade below the V shape, which really looks like it's on the outside of the V shape. And let's see, let's try one more. If I have an example where, let's say I've got 1/2 and then just x. So I'm not moving left or right, but I do have this 1/2 in front of the absolute value, which does, it's called a compression. So that means that I start on 0, 0, but instead of going up 1 into the right 1, I'm going up 1 into the right 2. So that really just makes, and I go up into the left 2 as well. So it really just makes my graph wider. Okay, and I didn't have any shading on